This old U.S. Defense Department film footage shows an Austin single-cylinder motor roller assigned to one of the U.S. Army Engineer battalions repairing roads in France in 1918. The manufacturer of this roller, the Austin Western Road Machinery Company of Chicago, supplied about 700 motor and steam road rollers to the Allied armies at the front during World War I. At one time, Austin Western Road Machinery Company and later Austin Western Company were highly innovative companies in the road construction business, producing a wide range of equipment from the early 20th century until 1973, when they were acquired by Clark International and ceased to exist with them in the 1980s. In the early 1900s, FC Austin Manufacturing Company of Chicago, Illinois, and Western Wheeled Scraper Company of Aurora, Illinois, merged to form Austin Western Road Machinery Company, headquartered in Chicago. Before that, both manufacturers had been developing in the same direction, producing various construction machines. FC Austin Manufacturing had been around since 1859, producing road construction machines, as well as drilling rigs and pipes. It should be noted that they had no relation to the English Austin Motor Company. And Western Wheeled Scraper was formed in 1891 on the basis of C. H. Smith and Company of Mount Pleasant, Iowa. In turn, C. H. Smith and Company was formed in 1877 by fellow workers from a railroad construction company to produce a crude wool scraper that held about 1/2 a cubic yard and was intended to make their work easier by replacing the tools of the day, a pick, shovel, and wheelbarrow, as well as an early type of scraper drag. Austin Western Road Machinery products were sold under the Austin and Western brands. Since 1934, the two manufacturers have operated as a single entity as Austin Western Companies, headquartered in Chicago. Austin Western Road Machinery consolidated its position developing new implements. In 1904, the company also manufactured railroad dump cars with 12 cubic yard capacity, operated by air. The capacity was soon increased by over 50%. These cars became the backbone of earth-moving operations that enabled the Panama Canal to be constructed ahead of schedule and below budget. The company began manufacturing road rollers circa 1906. In this case, their three-wheeled Austin single-cylinder motor roller of those years is shown. Although at first glance it looks like a steam engine, it is not. This roller does not emit smoke or sparks when moving. It does not require boiler maintenance and does not need coal or a supply of water, as it is driven by an internal combustion engine. The smokestack-shaped part serves as an element of the engine cooling system. It works like an ejector. The exhaust gases, passing through the stack, create a draft for the outside air, which provides some cooling. And such a lazy sound the roller makes because its engine has only one cylinder, but despite this, it did its job better and was 25% more economical than similar steam rollers. Rollers with this type of engine were built in 3 sizes: 8-ton, 10-ton, and 12-ton. Some data on the 10-ton will follow. The engine and all the mechanisms of the roller were installed on the main frame. It consisted of 2 longitudinal vertical iron sheets, cut in the front part along an arc and connected to each other at the rear by a cooling water tank, at the front by a cast iron-shaped casting, and in the middle part by the engine frame. The rims of the drums were connected to the hubs by means of spokes. The material for the spokes was iron. For the rim and hub, high-quality cast iron. This allowed the use of the rollers for 20 years or more without replacing the rims of the drums. One rear drum with a rim diameter of 1,780 millimeters and a width of 500 millimeters created a specific pressure on the ground of 70 kilograms per square centimeter. The front drum, which was turned by a worm and chain device, served to change the direction of the roller. When turning the steering wheel, The operator's force was transmitted through the steering shaft with the worm at its end and the worm wheel to the transverse shaft rotating in bearings fixed in the front part of the main frame. Two drums were mounted on the protruding ends of the transverse shaft, on which two chains were wound during rotation. The opposite ends of the chains were fixed to the axis of the front drum. With the worm gear, the front drum turned without much effort, but the chains made the system non-rigid, so when the roller was moving, especially in reverse, the front drum wobbled from side to side. This did not allow the roller to move in a straight line. As a result of transmission wear and sagging chains, the steering wheel received a large free play, which also made it difficult to control the roller. Also, when the roller moved along the minimum turning radius, due to the lack of differentials in the transmission, both the inner rear drum and the front one slipped a lot, as a result of which it was not possible to follow the correct circle. The roller was equipped with a horizontal single-cylinder 4-stroke internal combustion engine with a capacity of about 30 horsepower at 200 RPM. It could run on gasoline, kerosene, or denatured alcohol. The combustible mixture was formed by a spray-type carburetor with separate float and mixing chambers. It was ignited by a low-voltage magneto driven by the crankshaft. The engine power was regulated by the quantity and quality of the combustible mixture supplied to it. This was done by an automatic centrifugal regulator and manual levers. The fuel was supplied from the fuel tank to the carburetor by gravity. The engine cylinder was a powerful casting made of special cast iron with a water-cooling jacket. At the rear of the cylinder head with the intake and exhaust valves was bolted to it and also had a water jacket for cooling. The engine cooling system, which held 500 liters of water, was of the circulation type, in which a centrifugal pump supplied water from the cooling water tank to the cylinder and head jackets and then returned it back to the tank. The centrifugal pump was driven by a belt from the crankshaft. To monitor the water circulation, there was a sight glass in the pipeline. The cylinder piston was made of cast iron and had 5 rings. The camshaft, or engine side shaft, was located on the right side of the cylinder, perpendicular to the crankshaft, and received movement from the crankshaft gear. The crankshaft was located in front of the cylinder and rotated in bearings, and 2 massive flywheels were attached to it to ensure smooth movement. Lubrication of the rubbing parts of the engine was done using oil droppers without forced pressure. 1.5 kilograms of lubricant was consumed for every 8 hours of roller operation. The rotational movement of the crankshaft was transmitted to the rear drive drums of the roller via a transmission. The basis of the transmission is a system of gear wheels. In various combinations of engagement of gear wheels with each other, the movement of the roller was ensured at speeds of 1.8 kilometers per hour and 1.5 kilometers per hour both forward and backward. The rotation of the crankshaft was transmitted to the intermediate shaft through a pair of gears. This intermediate shaft had 2 friction clutches that, by means of a movable pusher mounted on the same shaft, could engage the gears of the direction of movement. These gears rotated the corresponding gears of the second intermediate shaft, and an idler gear was added to the port side gear, due to which the direction of rotation of the shaft was changed. The movable pusher was controlled by a lever from the operator's seat. Then the rotation was transmitted to the speed shaft through 2 gears of different sizes. They were engaged in operation one or the other also by means of a movable pusher mounted on this shaft, and thus changing the speed of rotation. Eventually, the rotation was transmitted to the output shaft, which drove the rear drive drums of the roller. The roller was controlled from the operator's platform. The following controls were concentrated there: steering wheel, gear shift handle, forward and backward clutch engagement handle, fuel mixture supply adjustment handles, foot brake pedal, handbrake handle, decompressor lever. In addition, under the mechanic's hands and supervision are the tap for gasoline from the tank, the tap for kerosene, the filler cap for water. The operator's platform was 640 millimeters wide and had no seat. Austin Western Road Machinery Company manufactured 3-wheel rollers and tandem rollers of various sizes and with various engine types and capacities, including steamrollers, which earned a reputation as reliable machines on construction sites in many countries around the world. Austin was the first to build a motor roller in the United States. A remarkable model in this direction was also the roll-a-plane roller with an additional drum installed in the middle part. This design allowed, if necessary, to concentrate up to 85% of the total weight of the roller as a payload on the middle roller. This method was used when it was necessary to avoid waviness of the surface processed by the roller, for example in the construction of airfield runways. The operation of the middle roller was controlled hydraulically.